Hi class. In this video we're going to talk about initial value problems. And the idea here is that you solve them like regular differential equations and then you have to do a few extra steps of algebra at the end. So we're going to, for example, do number 2. We're going to start with number 2. We have 2y prime minus y equals e to the x, and our initial condition here is that y of 0 is the natural log of 2. So what we want to do is first find the homogeneous solution. By identifying and solving the auxiliary equation. Here we get m equals 1/2. So the homogeneous solution is c e to the 1/2 x. And now we have a choice here on whether or not we want to use variation of parameters or the method of undetermined coefficients. And in this case, since the homogeneous solution does not overlap the g of x term, it's probably easiest to use the method of undetermined coefficients. That's not always the case, but when you can, you may as well solve one equation with one unknown. yp prime is a e to the x. So when I plug this in, what I get is 2yp prime minus yp. So 2yp prime is just 2a e to the x, minus yp is just negative a e to the x. So I'm supposed to get e to the x, but what I actually get is a e to the x, which tells me that that 1 equals a. So I can conclude that yp is just e to the x. That was lucky. So the general solution then is given by y equals yp plus yh, but I actually need to know what those things are. That's e to the x plus c e to the 1/2 x. Now, where does my initial condition come in? What's supposed to happen is if I plug in 0, I'm to get natural log of 2. So what I'm going to do is just use that information to solve for this c, this parameter c. So let's see, natural log of 2 equals y of 0, but if I plug in 0 over here, I get 1 plus c times 1, so 1 plus c. Solving for c tells us that c is natural log of 2 minus 1. And so ultimately, the solution to our initial value problem is e to the x plus log 2 minus 1 times e to the 1/2 x. So we can see that the initial value part only comes in at the end after we've found the general solution. And typically all we have to do is plug in this value, or values if it's second order or whatever, and we're going to get some equations which allow us to solve for the parameters in the problem. Okay, let's try another one. This one will be second order to show you what happens in that situation. This one is number 10. We have y double prime plus 2y prime plus 2y equals 2x squared plus 8x plus 4. And our initial condition is that y of 0 is the natural log of 2 again for some reason, and y prime of 0 is e. These numbers are more or less immaterial, at least for constant coefficient equations they are. Once again, we start with the auxiliary equation. In this case, we get m squared plus 2m plus 2 equals 0. Completing the square on this, we get m squared plus 1 equals 0. And finally, solving for m, we get negative 1 plus or minus I. this has complex roots, so the homogeneous solution is found just via this -1, and the coefficient of I here is 1. So it's C1 e to the negative x cosine x plus C2 e to the negative x sine x. All right, well now I know my homogeneous solution, so I need to know the particular solution, and here we have a polynomial. And in this case, it's actually once again easier to use method of undetermined coefficients. We don't really have to, but I don't want to do integration by parts over and over again, which I would have to do for variation of parameters. Okay, excuse me. So we're going to guess the solution as the quadratic polynomial ax squared plus bx plus c. Yp prime is 2ax plus b, and yp double prime is just 2a. All right, when I plug this back into the differential equation, I get, so let's see, it should be yp double prime plus 2yp prime plus 2yp. So I'll get 2a. This should be 2b plus 4ax, and 2yp should be 2c plus 2bx plus 2ax squared. And I'm supposed to get 2x squared plus 8x plus 4 on the left. And on the right, what I actually get if I collect terms is 2a plus 2b plus 2c. I start off with my constant term in this situation. 4a plus 2b times x. And finally, 2a x squared. So I get my system of equations 2 equals 2a from here. 8 is 4a plus 2b. And 4 is 2a plus 2b plus 2c. Well, the solution of this isn't terrible because we can solve the first one easily and then plug it into the second one. The first one we should get a equals 1. For b, let's see, if this is 4a is 4, so I subtract and I get 4 over here divided by 2, then you get 2. So let's see, if this one's 2 and that one's, so this will be 2 plus 4 is 6. Subtract over, you'll get -2. Divided by 2 should be -1. So that y sub p is equal to x squared plus 2x minus 1. Okay, so this is the general solution is then given by yp plus yh, so x squared plus 2x minus 1 plus c1 e to the negative x cosine x plus c2 e to the negative x sine x. Okay, well, if I plug in 0, I know I'm supposed to get log of 2. But if I plug in 0 to the derivative, I'm supposed to get something else. I'm supposed to get e. So what I need to do up here is go ahead and take the derivative. Y prime is 2x plus 2 plus 0 plus c1 times, and I'm going to have to do the product rule here. I'm going to get negative e to the negative x cosine x, and then minus e to the negative x sine x, plus c2 times, similarly, I'm going to get, let's see, e to the negative x cosine x minus e to the negative x sine x. So now, plugging in my initial conditions, I should get the natural log of 2 equals y of 0. But if I plug in 0, I get 0, 0, minus 1. Cosine of 0 is 1, so I'm just going to get plus c1. Sine of 0 is 0, so this term vanishes as well. And excuse me, for y prime, I'll get e equals, well, that's y prime is 0. And then if I plug in 0 here, I'm going to get 2 plus, well, let's see, if I plug in 0, the sign term vanishes, so I just get minus c1 plus, and now if I plug in 0 here, that's going to be 1, that's going to be 1, so I'm just going to get plus c2. And so the system of equations I have to solve is not terrible. I can solve the first one because it's one equation with one unknown. I get c1 equals natural log of 2 plus 1. And then if I rearrange c2, I'll get c2 is e minus 2 plus c1, but that's equal to e minus 2 plus natural log of 2 plus 1, which is e plus log of 2 minus 1. So that tells us that the solution of our initial value problem is going to be y equals, well, let's see, c1 is just log of 2 plus 1, so log of 2 plus 1. E to the negative x cosine x plus c2, which is this horrible thing, e plus log 2 minus 1, times e to the negative x sine x, plus the particular solution, which is here, plus x squared plus 2x minus 1. And there we go. So once again, notice that we first find the general solution via whatever method that we're most comfortable with. Typically that's via an auxiliary equation, and then either undetermined coefficients or variation of parameters. Once we have this information, we need, well, if I had some information about the derivative, I have to take the derivative, then plug in our initial values, and we're just going to get another system of equations to solve. Just solve that system and plug it back in to your general solution, and that's your answer.